In this video, we'll be using the solving techniques of quadratic equations to solve application problems. Depending on the given problem, we will either solve the problem by factoring or using the quadratic formula. As applicable, final answers will be rounded to 3 significant figures. Example 1. The power output P of a generator is given by its voltage V, internal resistance R, and current I. We have the given equation where P is equal to V times I minus R times I squared. Find the two possible values for the current in amps when P is equal to 40 watts, V is equal to 13 volts, and R is equal to 1 ohm. First, we substitute the given values into the given equation. We get 40 is equal to 13I minus I squared. Now rearranging this equation by moving all the terms to one side, we get a quadratic equation that is equal to 0. In this case, this problem can be solved by factoring, but if you don't see the factorization immediately, it's fine to solve the problem by using the quadratic formula. You'll arrive at the same solution either way. We need two numbers that multiply to 40 and add to negative 13. For this, we can use negative 5i and negative 8i, and factoring by grouping, we can factor out an I and we get I minus 5, and then factor out a negative 8 and we're left with I minus 5 again. Common factor out the I minus 5 and we're left with I minus 8. For this equation to be true, it means that either I minus 5 is equal to 0 or I minus 8 is equal to 0. For I is equal to positive 5 and I is equal to positive 8. And we have units of amps in both cases. In the original question, we were asked to find the two possible values of I that satisfy this equation, and here we can recognize that those values are 5 amps as well as 8 amps. Let's try another problem. Number 2. Under certain conditions, the distance s that an explosion propels an object above the ground is given by the equation s is equal to 143t minus 16t squared, where t is the time in seconds. After what amount of time is the object 60 feet above the ground? The key part of this question is the fact that we're asked to find the amount of time, so t, when the object is 60 feet above the ground. And that quantity represents the variable s. Therefore, we can write this problem as being, so find variable t for s is equal to 60 feet. Subbing in that value, we get 60 is equal to 143t minus 16t squared. We can rearrange this equation so it's a quadratic equation that is equal to 0, moving everything to the left and placing them in order from to lowest powers of t. We get 16t squared minus 143t plus 60 is equal to 0. Now we can solve this problem using the quadratic formula with a is equal to 16, b is equal to negative 143, and c is equal to positive 60. Therefore, t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Subbing in the given values, we get minus negative 143 plus or minus the square root of negative 143 squared minus 4 times 16 times 60 all over 2 times 16. This simplifies to 143 plus or minus the square root of 16,609. Take the time to confirm this with your own calculator to verify that you can complete the calculation on your own. And don't forget to divide the numerator by 32. So we find our two values of t, one with the plus sign in the equation, and the second one with the minus sign. We get that two values. Now we'll have to these values to three significant figures once we calculate them. Remember, when you're calculating these values all in one step in your calculator, you'll need brackets in the numerator of your fractions. And we find that the first value is 8.50 seconds when rounded to 3 sig figs, and the second value is 0.441 seconds. Graphically, what this problem looks like is we have the height above the ground, S, the amount of time that has passed, which we call t, and we have a parabola that opens down. You can see that the maximum height is reached up here at the vertex, and we're looking specifically for when the height is 60 feet above the ground. So we can see that that occurs at two different values of time, the first of which would be our 0.441, and the second of which would be 8.50 seconds. Therefore, the object is 60 feet above the ground after 0.441 seconds and 8.50 seconds. Looking at a third application problem, if a ball is tossed into the air, its height h, given in feet, is recorded and represented by the quadratic equation h is equal to negative 16t squared plus 22t plus 100, where t represents the time in seconds. Determine when the ball will reach a height of 80 feet. The method used to solve this problem is very similar to what we did in question 2. Try it for yourself and compare your solution to what is written here. When we solve this problem, we find that there are two possible solutions. One is negative 0.625 seconds and the other is 2 seconds. One thing we know about time is that we can't consider negative time. Therefore, one of these solutions is inadmissible, and we only consider the solution of 2 seconds. Therefore, the ball will be 80 feet above the ground after 2 seconds. So please go practice more application problems involving solving quadratic equations, and in the next video we'll look at the general quadratic equation, the vertex form, and completing the square to put a quadratic equation into the vertex form. And that will lead into our final topic of graphing quadratic equations.